Greetings to you all. Happy new month to you all. Today we are going to be talking about fundamental and derived units. Fundamental and derived units. Fundamental / derived units. Fundamental and derived units. Now, to fully understand this, we have to look at the concepts involved. Now we have fundamental. What does it mean for something to be fundamental? It means that thing is very important. That thing is like the standard. Is the standard. Everything dwells on it. Every principle comes from it. That means without it, it is not complete. That is for fundamental. Derived means from something I am getting this thing. That means this produced what we have today. So fundamental, the standard, the principle, everything comes from there. Derived, we get all those things from there. Everything emanates from there. But fundamental, that is the main thing. Derived is gotten from fundamental. So now we're going to start. Fundamental units. They are the main units. They are the standard of which every physics or every physical unit is used. So we are going to focus our fundamental units on 3 fundamental units. Fundamental units. So our focus is going to be on 3 things. What are these 3 things? The first one is mass, length, and time. Mass, which is m, length, which is l, and time, which is t. These are the 3 things that serves as the standard. Mass, length, and time. So some persons will be saying weight and mass are the same. Left to me, weight and mass are not the same. There is a difference between weight and mass. That is one. So now, how are we going to go about this? How are we going to focus this or use this to solve questions? How are we going to go about this? So I'll also come back to this and say mass is measured in kilograms. We can also say it's measured in grams. So we are saying kilogram or grams. Length, we are focusing our attention on meters or centimeters. For time, our focus is what? Seconds. Our focus is seconds. So we have the fundamental unit and we have the derived unit. So where we are now going to, we are going to, when we are going to derived unit now. Derived unit. Let's say, for example, we are looking at velocity. Let's say we are looking at velocity. Let's say we are looking at acceleration. Let's say we are looking at acceleration. Let's say we are looking at okay, let's work with these 2. The first thing, velocity, and we'll talk about acceleration. What is the formula for velocity? Today we are going to deal on some of these formulas. First one, velocity is equal to displacement over time. That's the formula for velocity. Displacement over time. The way I usually tell my students, displacement is a form of length. displacement is a form of length. So velocity is m. You see this, length is L, right? L. So L, what is time here? T. So that means to get velocity, dimension of velocity is L T inverse. L T inverse. You see, we just talked about now that there are three major fundamental units which we have to understand: mass, length, and time. If you can understand that we have mass, length, and time, every other thing serves as what? Every other thing comes from these three things: mass, length, and what? Time. So mass, m, length, L, t, which is what? Seconds. So we'll start from there. Velocity is displacement over time, which is L per t. See this, right? The next one is acceleration. Acceleration is the change in velocity per unit time. Change in velocity per unit what? Time. Change in velocity per unit time. So what are we going to do? We are going to use our knowledge of velocity to put it on top. Then we are now coming here to say we are still dividing it by what? Time. That means this velocity acceleration now is going to be L per t square. There's a difference, right? We have the velocity, which is length per time over time. So if we are taking this t up again, it will still be another inverse, which is LT raised to power what? Minus 2. LT raised to power minus 2. So like I said, the units, the fundamental units we have the mass, which is measured in kilogram or gram, depending on the unit. You know, in physics, depends on the unit you are given. The unit will determine what you use. The unit will determine the principle. You understand? You have to focus on the units. I tell them, don't just solve questions without knowing the unit. Then length. Length is L, which is in meters or centimeters. Time, which is T, which is in seconds. Derived unit, velocity, for example, we have velocity. Understand that velocity is displacement over time. Acceleration, which is change in velocity over time, which is LT raised to power minus 1 over T, which is equal to LT raised to power minus 2. Now, moving on, let us see if we can understand some other things today. Apart from understanding fundamental and derived units, I will also talk about scalar quantity and vector quantity.